Question asks, at standard temperature and pressure, 0.280 liters of a gas weighs 0.400 grams. Calculate the molar mass of the gas. There are a number of ways in which you can tackle this problem. You know the molar mass, or molecular mass, is the number of grams per mole. So you know in the end you need to find the number of grams per mole of this substance. So as long as you can identify grams and moles, you'll get the correct answer. In the problem, you're given standard temperature and pressure, STP. Standard temperature is 273 Kelvin. Pressure, 1 atmosphere. You're given a volume equal to 0.280 liters, and you're also given a mass. So you're given a gram amount. You will always have R, because we're dealing with atmospheres. Our R value is 0.281, and that's going to be the pressure volume on top. So that'd be atmospheres per liters, mole, Kelvin. So you're given temperature, pressure, volume, mass, R, only given one of each of those. So because you're only given one of each of those, you're not able to use the combined gas law. You're going to be either using the ideal gas law, the ideal gas law rearranged to solve for the molecular mass, which is the molecular mass equals a density, RT over P, or you could actually use molar volume. In this case, you can use the molar volume relationship as 22.4 liters of any gas if you have a single mole of it. You can use the relationship that a mole of any gas at standard temperature and pressure occupies 22.4 liters. This is only true if you have the gas at STP. If it's not at STP, you're going to have to use one of these two options right here. So I'll show you how to use all three of them. First off, if we were going to use the PV equals nRT to solve this problem, we would need to, in the end, remember, we need a grams per mole. Well, we have grams right here, so we need to know moles. So we could use PV equals nRT, N, and solve for moles. Plug everything in. Our pressure is 1 atmosphere. Our volume, so the volume is 0.280 liters. The R value, 0.0821, and the temperature is 273. Solve for N, and you're going to get a mole amount of 0.0125 moles. Take the number of grams that you have, divide that by the mole amount that you just determined, and you get a molar mass of 32 grams per mole. Actually 32.0 grams per mole, but it's 32 grams per mole. That's using the PV equals nRT formula. Well, you could also use the molecular mass equation because you're given enough information to determine density. Remember, density is mass per volume. You have a mass and you have a volume. So again, you can fill everything in. You can take your mass, 0.40, divide that by your volume, 0.280, multiply that by your R value, multiply that by your temperature, divide that by your pressure of 1 atmosphere, and you're going to get a molecular mass of 32.0 grams per mole. Or you can use this last relationship. To use this last relationship, we need to relate a volume and moles. So, take your volume. I will run this right down towards the bottom. Try to keep things somewhat organized here. So you take your volume, 0.280 liters. Use your molar mass. Or sorry, your molar volume, because it's at standard temperature and pressure. And you have to cancel out volume. So liters, 1 mole on top, And when you solve for it, you're going to get the same mole amount that you got previously. In both of these answers, your mole amount will end up being the 0.0125 moles, which, just like before, take your grams, divide that by your determined moles, and you get a molar mass, just like before, 32.0 grams per mole. So there are a number of ways that you can complete this problem. These two, you can always use, regardless of whether it's at standard temperature and pressure. Those two will always work out because they take into account the actual temperature, the actual pressure. The third, you can only use if it's at standard temperature and pressure. So if this problem was at not standard temperature and pressure, it had a pressure of 2 atmospheres, you would not be able to use the 22.4 liters per mole relationship. But any gas at STP occupies 22.4 liters. 1 mole of the gas occupies 22.4 liters. So you can always use that relationship if it's at STP. But whichever way you choose, you will get the right answer. You get the same answer. It's a 32.0 grams per mole.